Okay, today we're going to look at adding and subtracting like terms. So what are like terms? Like terms are terms that have the same variable and the same exponent with that variable or with those variables. Okay, let's look at some examples. Okay, so these are like terms: 6x, 4x, 3x, negative 2x, x, and that, etc., etc. What makes them like is they have, so notice that the numbers are different. So that's not what makes them like term. What makes them like is that they have the same variable here, and they have the same, so they have the same variable. See, they all have an x, and they also have the same exponent, which in this case is a 1. We don't write, I just made a circle. Maybe I should have put a, hold on. Don't put a 0. It's a 1. So they all have an understood 1 there, all of them. Okay? Okay, and I don't have to write them on all of them, but they all have an exponent of 1. That's what makes this a like term. That's what makes these like terms. Okay, so here, these are all like terms because they have the same variable, which is none, and those variables have the same exponent, which is 0. Okay, and of course, you know, instinctively we know that these can be combined easily. You can add 4 to 0, or 7, or 20. You can subtract it. Okay, so you see where this is like term. They both have an x and a y. This one both has an x and a y. This one also has an x and a y. So you can see that these are like terms. Okay, so these are like terms because they have an x, a y, and they also have this 3 here. Okay, that looks bad, doesn't it? Let's get rid of that. So it also has this 3. So the y is to the third power. So it's xy to the third power on each one of these. So because they have the same exponent and the same variable, then they are considered like terms. That means they can be added or subtracted together. Okay, so let's look at some examples. 6x plus 2. So they don't have the same variable or the same exponent. So they cannot be combined. This is as simple as that one gets. Okay, so now you have 6x plus 2x. So these can be combined because it has the same variable, which is x, and the same exponent, which is 1. So these can be combined. 6 plus 2, 8x. Okay, so here, x squared plus 2x plus 2, neither of these can be combined together. And the reason why I use that, because you're going to run into this one a lot. So I wanted you to see that once it gets to x squared plus 2x plus 2, oh, x to the second power, x to the first power, and then x to the 0 power, or no x. That is as simplified as that one can get. Okay, so now let's look at some more examples. Okay, we have x squared minus 3x squared plus x minus 3 plus 3x plus 5. So we're going to look at this group of terms and see what we can add or subtract together. So where are our like terms? I like to start at the highest exponent. I can see that the highest exponent is a 2, so I'll start with the x squares. You have this one, the x squared, and you have the negative 3x squared. Those two are the only two that have an exponent of 2. So we can combine these. Remember this 1 that's not written that we know is there. So 1 minus 3 will be negative 2 Remember, we don't change the exponent values. So we don't combine the exponents, we just combine the numbers here. Okay, and then so we can, I would just cross these out so you won't look at them again. Then we have x to the first power. So we have x here, 1x and 3x. So those are both positive, so we can add them together to get 4x. Cross those out. Then we have negative 3 and positive 5. Combine them together to get positive 2. Okay. Now, simplify. Well, that's the answer. Now, again, we'll look at another one. We have x squared plus x minus 9x plus 9. Okay, you're going to run into this one a lot too, so this is why I use this one as an example. The only two that can be combined are the two in the middle. You'll see when you run into that when we start doing the FOIL method. Okay, so you have, so we see it's only one x squared that we can use. And then we have 1x minus 9x, which will give us minus 8x, and then minus 9, and that is as simplified as it can get. Okay. Okay, let's look at another one. Now here we have more than one variable within a term. So we have x squared and y, x squared times y together, and we have another one that says x squared times y. These two don't match, so we can combine this one and this one together. Remember that 1 that's not written, but we understand to be there. So this will be 2x squared y. Okay? So take a moment to absorb that right there. Okay? So you just combine the two like terms. This is how their terms are alike. It's because they have the same variables, x and y, and they have the same exponent. So the square is with the x. So if it was a square with the y, it would not be the same anymore. Okay, so then we have 5x squared minus 3x squared. So these two are also the same. So 5 minus 3 is 2x squared. Okay, simple enough, right? Okay, look at another one. Okay, we have negative 4 minus 6x plus 3 minus 9x. Okay, so I like to start with the highest exponent. That would be the ones here. So we have negative 6x and negative 9x. That would be negative 15x. And then we have negative 4 and positive 3, just negative 1. Okay, pretty simple, right? All right, now I put the answer either way. I like to see the exponent, and then exponents go down from high to low with a constant being at the end. But you may find this either way. That's just my preference. Well, it's not just my preference. It's the norm, but it is not the rule. All right, guys, you got it. Now, we'll do an exercise, a practice exercise, and we will see what you can do. Good job.